In this example, what we're going to be doing is we're going to be calculating all of the ions in a mixture. So, the example, if in 20 ml of 0.1 molar aluminium chloride solution is added to 30 ml of 0.1 molar magnesium chloride solution, calculate the concentration of aluminium ions, magnesium ions, and chloride ions in the final solution. Now, the key point that you need to know is concentrations are not additive. So you can't just add 0.1 for aluminium chloride to 0.1 for magnesium chloride to work out the concentration of the chloride ions. It's just not possible because concentrations are dependent on the actual volume. So if you want to work out the concentration of the chloride ions, which is in both solutions, you need to find the moles. So when we tackle this problem, we're going to find the moles of each component, and then we can add a mole, because moles are additive because it's an actual number of particles. So I'm going to break the problem down into each solution. So solution 1 will be the aluminium chloride. Solution 2 will be the magnesium chloride, and then we'll put it all together to make solution 3, the new mix. So in solution 1, we've got 20 ml of 0.1 molar aluminium chloride solution. Now remember, aluminium chloride does not exist stuck together. It exists dissociated because it's an ionic compound that is fully soluble. So if the aluminium chloride solution is 0.1 molar, then the concentration of the aluminium ions will also be 0.1 molar because it's a 1-to-1 ratio. And the concentration of the chloride ions will be 0.3 molar because it's a 1:3 ratio. So the number of moles then of aluminium ions will equal CV, which is 0.1 times 0.02, because we must convert our volume into litres, is 0.002 moles. The number of moles of the chloride ions would equal CV, which is 0.3 times 0.02, which is 0.006 moles. So now let's look at solution 2. Our magnesium chloride does not exist stuck together. It's fully dissociated. So you have magnesium ions and chloride ions. So if we have 0.1 mole per litre of magnesium chloride, look at the equation. The ratio is 1-to-1 for magnesium ions. So you have 0.1 moles per litre of magnesium ions and 0.2 moles per litre of chloride ions because it's a 1-to-2 ratio. Now we can find the number of moles. So the number of moles of magnesium ions will equal CV, which is 0.1 times 30 ml. Now the ml must be converted into litres. So it's 0.03 of a litre. So this comes out to 0.003 moles. The number of moles of chloride ions equals CV, which is 0.2 times the volume, which is 30 ml, which is going to be equal to 0.006 moles. Now we're going to look at doing the concentration of the new solution. So now we're going to find the concentration of each of the ions in the new solution. But first we need to know the volume. Volumes are additive. So our total volume will equal 20 ml, add 30 ml, which is equal to 50 ml. And remember, this will need to be converted into litres, which is 0.05 of a litre. So now we can find the concentration of each ion. So the concentration of aluminium ions is equal to number of moles over volume, which is 0.002 divided by 0.05. So this equals 0.002 divided by 0.05, 0.04 moles per litre. Now, we're going to do the easy ones first. So the concentration of the magnesium ions is going to be equal to N on V, which is going to be equal to 0.003 divided by 0.05, which will come out to 0.06 moles per litre. Now, the chloride ions come from both solutions. So we can add moles because it's an actual number of particles independent of the volume. So the total number of moles of chloride ions would equal 0.006 add 0.006, which is 0.012 moles. So the concentration of the chloride ions is equal to N on V, which is 0.012 divided by 0.05, and it comes out to 0.24 moles per litre.